Hey guys, so let's quickly talk about hands-on with services. So we are about to get hands-on and put the theory to the test. We will augment a simple single pod app with a Kubernetes services, and we will show how to do it in two ways. The imperative way, which is only which is used in emergencies, and the declarative way. So the imperative way actually is not the Kubernetes ways. It introduced the risk that changes made imperatively never make it into declarative manifest, rendering the manifest stale. This introduced the risk that the stale manifests are used to update the cluster at a later date, unintentionally overwriting the changes that were made imperatively. Now, use the kubectl1 command to declaratively deploy the following replica set. Yes, we are about to do things imperatively. The command assumes the replica set is defined in a file called rs.yaml and has the following content as you can see in the screen. You do not have to complete this step if you still feel and have the replica set running from previous example. Example you can see here. Now that the replica set is running, it's time to imperatively deploy a service for it. Use the following kubectl1 command to create a new service that will provide networking and load balancing for the pods deployed in the previous step. This you can see here. Now let's explain what the command is doing. So kubectl1 expose is the imperative way to create a new service object. The web-rs is telling Kubernetes to expose the web-rs replica set that we created previously. Name is equal to hello-svc tells Kubernetes that we want to call this service hello svc, and target port 8080 tells it which port the app is listening on. This is not the cluster-wide port that we will access the service on. So finally, hyphen type is equal to node port tells Kubernetes we want a cluster-wide port for the service. Now, once the service is created, you can inspect it with the kubectl1 describe svc hello -svc command, as you can see here. Okay, so let's discuss some interesting values in the output above. So number one, selector is the list of label that pods must have if they want to match the service. Number two, IP is the permanent virtual IP of the service on the pod network. Number three, port is the port that the app listens on. Number four, node port is the cluster-wide port. And finally, endpoint is the dynamic list of pods that currently match the services label selector. Now that we know the cluster-wide port that the service is accessible on, we can open a web browser and access the app. In order to do this, you will need to know the IP address of at least one of the nodes in your cluster. It will need to be an IP address that you reach from the browser, example a publicly routable IP if you will be accessing via the internet. Now let's take an example of some random IP with the port detail. Now let's see. Let's take an example of a web browser accessing a cluster node with an IP address anything. We can take random on the cluster wide port, and again that can be a random. The app we have deployed is a simple web app. It is built to listen on port specified, and we have configured a Kubernetes service to map port on every cluster node back to port 8080 or whatever you have taken as an example on the app. Now by default, cluster wide ports are between 30,000 to 32,767. Coming up next, we are going to see how to do the same thing the proper way, the declarative way. To do that, we need to clean up by deleting the service we just created. We can do this with the kubeact t1 delete svc command. You can see this command here. Now let's talk about the declarative way. And this is the Kubernetes way as well. So a service manifest file, we will use the following service manifest file as you can see at the bottom of the screen, to deploy the same service that we deployed in the previous section. So the difference is this time we will specify a value for the cluster wide port. Let's step through some of the lines. Now if you see this program, services are mature objects and are fully defined in the v1 API, which is .api version. The .kind field tells Kubernetes to pass the manifest to the service controller for deployment as a service. The .metadata section defines a name and a label for the service. The label here is a label for the service itself and not the label that the service uses as its selector. The .spec section is where we actually define the service. In this example, we are telling Kubernetes to deploy a node port service. Other types such as cluster IP and load balancer exist, and to map port whatever specified from the app to port 30001 on each node in the cluster. Then we are explicitly telling it to use TCP. Finally, spec.selector tells the service to select on all ports in the cluster that have the app is equal to hello-word label. This means that it will provide stable networking and load balancing across all pods with that label. Okay, let's quickly move to common services type. The three common services type include 1. Cluster IP, 2. Node port, 3. Load balancer. Now cluster IP, this is a default option and gives the service a stable IP address internally within the cluster. It will not make the service available outside of the cluster. Node port, this builds on top of cluster IP and adds a cluster-wide TCP or UDP port. It makes the service available outside of the cluster on this port. And finally, load balancer. This builds on top of node port and integrates with cloud native load balancers. The manifest needs POSting to the API server. The simplest way to do this is with kubeact t1 create, as we have done it earlier as well. Okay, yeah. This, and you can see on the screen right now, this command tells Kubernetes to deploy a new object from a file called svc.yml. The -f flag lets you tell Kubernetes which manifest file to use. Kubernetes knows to deploy a service object based on the value of the .kind field in the manifest. Okay, so this completes one small portion. I'm taking a pause here. In the next lecture, we would be talking about few other, details of services. Till then, thank you very much. Stay tuned, work hard. Thank you.